right. So we're gonna do the last two pages of yesterday's and the first page of this one, because the first page of this one kind of is a standalone thing, so I'm gonna do that today. So it's only 3 slides. So next week, there's still gonna be some, testing upstairs in our room, so we're gonna come here next week. They keep changing days around, so instead of figuring out when we're supposed to go where, we'll just, stay here next week also, okay? All right, so today, like I said, we are going to, first of all, finish yesterday's, we have 2 problems on there, and then we'll do 1 page of section 8.6. So one of the types of questions you can have with what we did yesterday is you can have a question that has 2 different angles of elevation or angles of depression. So this one says Vernon is on the top deck of a cruise ship and observes 2 dolphins following each other directly away from the ship in a straight line. So Vernon is up here looking at these 2 dolphins down here. It says Vernon's position is 154 meters above sea level, so this is the 154. And then the angles of depression to the 2 dolphins, one is 35 and one is 36. Now again, what I do is I put those down below in here. So this one is 36, this one's 35. Now it really doesn't matter which one you put where, because we're going to end up taking those triangles and separating them, and we're gonna have 2 separate triangles. So it doesn't really matter which one you call 35 and which one you call 36. Now, what they want us to find out here is this distance, okay? So I'll try to explain what we do here. We end up doing one triangle where we find this, and I usually call that X, okay? Then we do the larger triangle, which would be this distance, okay? So that would be the whole distance down here, and I call that Y. And then in the end, what we want to do is find this green distance, which we can call Z. And does it make sense to you guys? If you found the bigger distance and subtracted the smaller distance, it would give you that distance between. So in the end, you're gonna take your bigger side length on the bottom, subtract the smaller, and that will give you the distance between those dolphins. So you end up doing 2 separate triangles, okay? So one of those triangles is going to be, let's see here. So you're gonna have 2 different ones, and like I said, it really does not matter which one you call the 35-degree angle and which one you call the 36-degree angle. So I'm gonna say this is 35, this is 36, this was 154 meters, this is 154 meters, and then 2, which one you call X and which one you call Y down below doesn't really matter. It's just at the end, you're always gonna take the bigger one and subtract the smaller one. But the way I labeled it up here is I called this X and I called this one Y, okay? Now, do you guys see we're gonna end up doing two tangent problems, right? So, oops. So when I go to do this, here's my angle. So this is opposite, this is adjacent. In this one too, this is opposite, this is adjacent. So what trig function is each of those? It's tangent. So what I can do is go tangent of my 35-degree angle is opposite, which is 154, over y. And then here, I would do that same thing, okay? So in this one, I would do tangent of 36 equals opposite, which is 154, over adjacent, which is x. Now, are these ones where we do cross products or second tan? Cross products. So if I go back here and put this over 1, I multiply here, I get tangent 35y equals 154. And then I'm going to divide by tangent 35. Okay. And y would equal, so if we look at our calculators, this is 154 divided by tangent 35. And that is 219.93. Okay. Then I'm going to come over here and do the same thing. So when I do cross products, I'd get tangent 36x equals 154. And I divide by tangent 36. And when I do that, I get 154 divided by tangent 36 is 211.96. All right. Then what I'm going to do for my very last step, remember what we want to do is we want to find this little distance, so we're going to take and subtract our two distances on the bottom. So even if you didn't really pay attention to which one is which, you would always just take the biggest one and subtract the smallest one. So our z would be 219.93 minus 211.96. And if I type that in, I got 7.97. Is that what you guys got? Okay. So 7.97, and that is in meters. That would be our answer. Okay, so basically if you have the two triangles, you just separate them and then do two different trig functions and then subtract. Now this one here, it says two buildings are sited from atop a 200-meter skyscraper, okay? Building A is sited at a 35-degree angle of depression, and building B is sited at a 36-degree angle of depression. How far apart are the two buildings, okay? So I'm a horrible drawer, but it's kind of like you have this building here, and there's somebody up here looking down at, I'm gonna just put a straight line for one of the buildings, and then they're looking at straight down at a second building, okay? So it's kind of like this, And what we're going to do, it says, how far apart, oh, no, I'm lying there. Sorry. So somebody's up here, so this distance is 200 meters, and the buildings are actually down here. So that building is just 200 meters higher than the other two, okay? And you're looking down on these two buildings, and again, what you truly have is these two angles of depression, and one of them would be 35, one would be 36, okay? But what I would do on this then is I would just close these buildings in like this, and I would put the 36 here and the 35 here. So you're gonna end up having two triangles again. Okay, you know this is 200, and you know this is 36 degrees, and then you have another one which is 200, and this one is 35 degrees, and what you want to do is see how far apart are these two right here. Okay, so you could right away, just instead of drawing that, you could go to and separate the two triangles. You can call this one Y and this one X, and then at the end you're going to subtract. Okay, so again with these we have a tangent, so we're going to say tangent 36 equals 200 over X. So I'm going to cross multiply, and I get tangent 36 equals 200. And, oh, there's an X in there too. Tangent 36, X equals 200. And then I'm going to divide by tangent 36. And when I do that, X is going to equal 200 divided by tangent 36, and that is 275.28. Okay, then if we go over to this one here, it's also tangent, so it's going to be tangent 35 equals 200 over Y. And then we put this over 1, we get tangent 35y equals 200. Divide by tangent 35. And y would equal, if I do my 200 divided by tangent 35, I get 285.63. And then again, you always take the biggest one minus the smaller one. So our z is going to be 285.63 minus 275.28. Did anyone figure these out? Did you get those two numbers too? Okay. And then when you subtract that, did you get like 10.35? Okay. 10.35 meters would be your answer there. Okay. All right. So that is the last part of yesterday's, and now I'm going to show you today's, just the first sheet. Now, can you guys take out your cheat sheet that I gave you guys yesterday? The janitor did find one on the floor, so I wonder if somebody left it here. Or was anyone not here yesterday that doesn't have it? It looks like this. Everybody okay? Now, on this cheat sheet, I couldn't fit it on the front and still fit these tables. So what I did, what I'm teaching right now is actually on the bottom of the back. Okay, that's what we're gonna be using. And what we're gonna do is learn how to find, when you get into this section, 8-6, we no longer have right triangles. Everything we did so far in chapter 8, we had a right triangle. Starting in section 8-6, we have what's called an oblique triangle, and they do not have a right angle. So everything that we've learned so far is going to be different in section 8-6 and 8-7. So what we're gonna do first with these oblique triangles is we're gonna find, how do you find the area of them? Now, if you had a right triangle, I don't know if you guys remember this or not, but you can find the area of that by going 1/2 base times the perpendicular height. Do you remember doing that? Even if you had something like this, where this whole thing is the base, but then you have that perpendicular height, you still can use 1/2 base times the height. But today what's gonna happen is we're not gonna have a perpendicular height. So there's a different way that we can find the area of a triangle, and this is what's on your cheat sheet. And one thing I want you to notice in this formula, it's 1/2, and then it's 2 sides times the sine of the angle that's not listed there for letters. So it's 2 sides times the sine of the angle that's not one of the sides. How that looks on a diagram is, you might know this is 5, this is 7, and this is 30 degrees. So it's always like a side angle side situation. Those are the ones that you use. Sometimes what they'll do today is they'll tell you that, they'll tell you this, and they'll tell you this, and then they'll give you 2 of the sides, and you're gonna wonder, like, how do I know which angle? Well, you could look at this, and that would tell you, or if it's on a diagram, you would just do side angle side, okay? So if we look down here, they have it drawn out for us. Do you guys get that this is side angle side? So then we really don't have to worry about which side is A, which side's B, what angle. When you have side angle side, you're always just gonna go 1/2 times the 2 sides, 6 times 3, times, and if you look, it's sine of the angle that is in between the 2 sides, so it's sine of 25. Now, if you don't like fractions, you can always do 0.5 when you plug that in, but then you're just gonna go ahead and plug that in. You're gonna go 0.5 times 6 times 3 times sine of 25. Did you guys get 3.80? Okay, so that would be your answer. And it's area. So what do you think my units would be? Centimeters squared. Very good. Okay, so you're always looking for side angle side. So if I'm doing this one, what, I know I have to use my 2 sides, okay? What angle would I use? So 36, so that it's side angle side. So I don't even really have to worry about which sides they are, which angle it is. I just go 1/2 times my 2 sides, so 8 times 14, times sine of 36. Okay. Now what I would do is punch in 0.5 times 8 times 14 sine 36, and we would get 32.92. And that would be in centimeters squared. Okay. Then when we go down and look at this last one, when we do this one, it's not drawn out. So then you're gonna wanna look, it's A, B for sides, and angle C. So it would be this formula. A and B are the sides, C is the angle. So you're just gonna multiply 1/2 times the two sides times sine of that angle. So if I do that, it's really 1/2 AB sine of C. Not that you really have to write that out, but you would just go 0.5 times 10 times 15 sine of 55. Okay? So we'd go 0.5 times 5 times 10 sine of 55. Did you guys get 20.48? Okay. All right. So for your assignment today, you're gonna have two shorter assignments. So I'm gonna go back to this page and give you the one on this first. So there's a worksheet. You're gonna go to page 33 and just do number 7. And I believe that's the same worksheet you guys worked on from yesterday. So you only go to the worksheet that has page 33 on the bottom and do number 7, and then you have these 4 problems, or these 3 also in the book. And once you copy that, then I'll show you what you're gonna do on the other section. Then for this assignment, so there's a worksheet, and this is what I taught last. You're gonna do those problems. So that's the one where you just go 0.5 times the two sides times the included angle. And you can do, can you guys write on the top for this? Just write section 8.5 day 2 and 8.6 day 1. I just wanted to say, because I give you guys the keys for most assignments, some kids are just turning in just the answers with no work at all, and I have no proof that you've done it then. So if you see that you get a 2 or a 3 on your assignment and I say show work or need to show work, that's why.